Okay, Wildcats, here we're on journal page 54, graphing more complicated rational functions. Example 1, enter the domain of the function using an inequality set notation and interval notation. For any x value excluded from the domain, select whether the function's graph has a vertical asymptote or hole at the x value. Using Desmos to check your answer. All right, so look at the denominator of the given function. The function is undefined at x equals. To find that, we set the denominator equal to 0. So x plus 3 equal to 0. Subtract 3 from both sides, x equals negative 3. So the function is undefined at negative 3. Complete the domain. The domain is affected by where the function is undefined, okay, by the denominator. So the inequality notation, x is less than negative 3 or x is greater than negative 3. In set notation, x does not equal negative 3. So in interval notation, it's from negative infinity to negative 3 or from negative 3 to infinity. When a rational function has a factor in the denominator that is not also in the numerator, and an infinite discontinuity occurs at the value of x for which the factor equals 0. On the graph of the function, an infinite discontinuity appears as a vertical asymptote. So the graph has a vertical asymptote at x equals negative 3. Okay, so let's go ahead and graph. Divide x plus 6 divided by x plus 3. And then I'm going to go ahead and graph x equals negative 3. And you can see here where the discontinuity is. Okay, so you can see x is less than negative 3, x is greater than negative 3, x does not equal negative 3, and it's from negative infinity to negative 3 or from negative 3 to infinity. Okay? All right, let's take a look at the next example. Example 2. Enter the domain of the function using an inequality set notation and interval notation. For any x value excluded from the domain, select whether the function's graph has a vertical asymptote or a hole at the x value. Using Desmos to check your answer. F of x equals x squared plus 4x minus 5 divided by x squared minus 4x plus 3. Factor the numerator and denominator to find the vertical asymptote and the hole. Okay? So we know 2 parentheses. We also know 2 parentheses here. Now let's go and factor the numerator first. We need to figure out what number multiplies to give you negative 5 combined to be 4. Since the middle number is positive, the bigger number is positive. So negative 1 times 5 is negative 5. Negative 1 plus 5 is 4. So we have our negative 5 and 4. So our factors are x minus 1, x plus 5. Now, we figure out what numbers multiply to give you 3 and combine to be negative 4. Since the middle number is negative and the last number is positive, we have to multiply by 2 negative numbers. So negative 1 times negative 3 is 3. Negative 1 minus 3 is negative 4. So we have our 3 and negative 4. So we have x minus 1, x minus 3. Now, x minus 1 divided by x minus 1 divides and becomes 1. Okay? That is where our hole is. Okay? We find our hole by setting x minus 1 equal to 0. Okay? We add 1 to both sides, so x equals 1. There is where our hole is. Okay, so we have a hole at x equals 1. Now, for the vertical asymptote, we set the remaining denominator equal to 0. So x minus 3 equal to 0. So we add 3 to both sides. So x equals 3 is our vertical asymptote. Okay, so the graph has a vertical asymptote at x equals 3. Okay, so let's take a look at the next step. All right, step 3, complete the domain in each form. So to understand where these numbers come from, let's go ahead and graph. Okay, so let's go ahead and divide x squared plus 4x minus 5 divided by x squared minus 4x plus 3. And let's go ahead and graph x equals 1 and x equals 3. So you can see here, this is where your hole is, and this is your asymptote, okay? So you can see that x is less than 1, okay? But then the graph is between 1 and 3, and then it's from x greater than 3, okay? Or you can see that x does not equal 1, x does not equal 3, or it comes from negative infinity to 1, 1 to 3, 3 to infinity, okay? So that graph basically explains this right here, okay? All right, let's take a look at the next example. All right, example 3. Divide the numerator by the denominator to write the function in the form quotient plus remainder divided by divisor, and determine the function's end behavior. Then enter the range using an inequality notation, or inequality and set notation and interval notation. Okay, so we divide. Second, I gotta fix my papers here. Okay. All right. So we ask ourselves, what do you multiply x by to give you 2x? The answer to that is 2. Now we multiply 2 times x is 2x. 2 times negative 2 is minus 4. Okay, we subtract. That becomes positive. This cancels. You get 1 plus 4 is 5. Okay. This is the quotient. This is the remainder. And then this is the divisor. Okay. So that's 2 plus 5 divided by x minus 2. Okay. Now, to understand the range, let's go ahead and graph the function. Okay. So you can either graph the 2x plus 1 divided by x minus 2, or you can graph the 2 plus 5 divided by x minus 2. You can see they're the same thing. But what you can see here is if I graph y equals 2, you can see that the graph is less than 2, it's greater than 2, it doesn't equal 2, and it comes from negative infinity to 2, from 2 to infinity. Okay, so that graph explains this range. Okay, take a look at the next example. Okay, example 4. Divide the numerator by the denominator. Okay, and put in the form of quotient plus remainder divided by divisor. Determine the function's end behavior, then enter the range using an inequality, set notation, interval notation. So we divide. Okay, so before we do that, we need to expand this. So that's x divided by x squared, x times plus 5x minus 4x minus 20, which simplifies to be x squared plus x minus 20, which this now becomes a divisor. So that's x squared plus x minus 20. And then this needs to be written as if this has an x squared, this has to have x squared. So this is going to be written as 0x squared plus x. Okay. Now, you ask yourself, what do you multiply x squared to give you 0x squared? The answer to that is 0. Since the degree of the numerator is less than the degree of the denominator, which means the quotient is 0. Step 2, enter the function. Then we can't write the function in this form. We just go back to the function is x divided by x minus 4x plus 5. Okay. Now let's go ahead and graph that and then take a look at the range. Okay. So we have x divided by x minus 4, x plus 5. Now, you can see that the domain has an effect, but the range is infinite in both directions. There's no asymptotes. Like if I graph, there's no horizontal lines that cuts to the graph, so it's infinite, okay? So that explains why it's from negative infinity to positive infinity, negative infinity to positive infinity, and so on, okay? All right, go ahead and finish up your notes and examples. Start working on your assignment. Have a wonderful Wildcat day.